All right. So we didn't quite get through all the material from module 3, so we'll kind of finish up what we didn't get through in the slides. We'll then start module 4 today. Should be able to get through it pretty easily this week. A little bit less material from module 4. It's almost like repeat material from module 3. So after Thursday's class, we're going to have what? A module 4 quiz. There will not be a module reading this next week because what is next Thursday? You should all have it marked out so you're making sure you're in class because there is an in-class exam. All right, so if you haven't done that, you really should make sure that you are here Thursday because there's no makeups for that exam. So we'll talk more about that as we get closer to it. We're just kind of painting a roadmap of where we're going. I did want to make a mention on quiz 2. There was one problem where I didn't want rounding to be an issue, but it was for, and honestly, none of you probably realized it. I think it only impacted like a handful of you, 5 or 6. But if you rounded up instead of down on one of them, it was counting as incorrect. I expanded it so it allowed you to round up or down to that. I think it was problem 5. So you might have seen kind of a quiz 2 regrade. Like I said, it probably only impacted 5 or 6. I don't even know if it was 5 or 6 across both the sections. So most of you probably didn't even realize it. But I just wanted to mention that since I did do that. Okay. Other than that, any questions for me before we kind of dive into module 3 material, kind of finish that up and move on to module 4 here today? Okay. All right. So we were talking last week about supply and demand, right? So in fact, before I even kind of get to this, we'll kind of start out drawing something today. So we were talking about that there is some relationship between the price of a good and the quantity demanded, okay? So if I was to put a demand curve on this graph, it tells me that at these different current prices, here are the various quantity demanded. All right, we got that from a demand schedule. We can get that from a demand equation. Excuse me. We said there's this inverse relationship. As the price goes down, how much are people going to want to buy or how much will they demand? It goes up. Right? Now, if I'm putting supply on the exact same graph, that's telling me the relationship between the price and not the quantity demanded, but the quantity supplied. So in general, I'll just kind of write this as quantity because it's all representing quantity. If we're on the demand curve, this quantity is representing a quantity demanded. If it's on the supply curve, it's representing a quantity supplied. Okay. So we talked about last class, how do I identify kind of this equilibrium, price and quantity, just the easy non-technical, it's technical, but not real technical. Where is that point at? Where supply is equal to demand. Or what am I really saying there? It's the price where the quantity demanded is the exact same as the quantity supplied. So what that's saying is currently the units that are being supplied to the market at that price are the exact same number as the amount of people, you can think about it, that want to buy that good. Now, obviously, it's like not just people, right? It's how someone can buy more than one, but it's easier to think about however many of these units are being supplied, there's that exact same demand. That's the exact same number that people want to purchase, okay, or consume. So, and now I have to remember what order I did the slides in. Hold on. I think I did surpluses first. Yeah. So let's think about, for whatever reason, if the current price, and I'll kind of say H here, like a hypothetical price. Let's say the current price of the good was above where we know that equilibrium price should be. What's going to be the case? Well, if the price is higher, just intuitively, before we even think about graphically and visually, if the price is above this equilibrium point, what's that going to do to my quantity demanded? Higher prices should decrease it. What's it going to do to my quantity supplied? More people are going to want to supply it, right, at higher prices. Well, the graph tells us that. If we had this hypothetical price, what ends up being true? My quantity supplied at that price is greater than my quantity demanded. So what we would call this, there's more units being supplied than people want to buy. So we've got two terms, shortages and surpluses. Which would this represent? A surplus, right? We've got too many. This is like a surplus store. They produce too many, people didn't want to buy them, so they send them to the store and sell them for really cheap, right? Because people didn't want to buy them at this higher price. So if we ever end up in this scenario where we have a surplus, well, what's going to happen? If I'm supplying units to the market, but nobody's buying them, how much am I really making from every single one of these units? Am I making the price? Well, there's no one to buy them. So I'm just producing them. We said we would be willing to produce them if I could charge this higher price. The problem is, if I'm charging this higher price, is anyone buying them? No. So how much? What's my marginal benefit to those units past the quantity demanded? Zero. Is that going to be above my marginal cost? No. Right? So when we have a surplus, these companies say, well, look, if we're charging this price, I'm not going to be selling any of these units to anyone. So what am I going to do? I'm going to start to produce less, which should lower the price, convince more consumers to buy them, until we get to this point where now all of the units I'm producing are being consumed. So anytime you start with a surplus, if we did for some reason end up with this hypothetically high price and we have the surplus of this good, the market pressures, well, if I'm not selling this good to anybody, what do I start doing? Producing less, right? I'm gonna move back down until we get to this point where we're at a price where the quantity supplied is equal to the quantity demanded. If I'm selling a good and nobody's buying it, what am I going to do? Intuitive. You're selling something, nobody's buying it. What might you try to do before you close your business down? Lower the price a little bit, stop producing these units that were at high cost, right? So when we have a surplus, what happens to that price? It kind of moves downward towards that equilibrium price, okay? Any questions on this idea? Okay. All right. So let's say I had a supply and demand schedule, right? I don't have the nice visual graph, but I've got kind of these numbers. So I could graph these out and I would get my demand and my supply curve, right? Prices and quantity demanded, prices and quantity supplied. If I had well, first of all, what's the equilibrium price here? Yeah, where does quantity demanded equal quantity supplied? At a price of 3. We just said if the price is above that, what are we going to have? A surplus. Sure enough, if the price is at 5 here, what is the number of units people want to buy? Or what's the quantity demanded? 9. How many would people want to supply if they could charge that price of 5 and sell it? 25 units. So if we had this artificial, hypothetically high price of 5, what would exist? A surplus of how many units? 16, right? Just the difference between those two. So we can identify not only is there a surplus, but how many units, right, are we over kind of supplying, if you want to think about it that way. Right? So these surplus values will always tell us the difference between the quantity supplied and the quantity demanded. When quantity supplied is greater than the quantity demanded, we have too many units, people don't want to buy them, we've got a surplus. We can get that from a table. We can get that visually from a graph. I kind of led with this, so sometimes I do things a little bit out of order of my slides. But these are just kind of here to go back to, in case you missed class or, I don't know, you weren't. Anytime I draw something up here, all of you should be drawing it down. Just throw, I've tried to reiterate this, but right, this is always good things to have, right? So, I already mentioned, if we do have this surplus, what happens? Well, if I'm not selling these units, nobody's buying them, I start to lower the price. As I lower the price, what happens? Well, the quantity demanded goes up. I'm willing to supply less to the market. What's happening to the value of that surplus? It's going down. What's it getting closer to? The equilibrium point where the surplus would be 0, right? If we've got my equilibrium, quantity supplied is exactly equal to the quantity demanded, there I have a surplus of 0, right? Now there's no incentive for me to lower the price anymore. Every unit I'm producing, I'm selling to somebody. Any questions here before we keep moving? Okay. I don't think that's too bad, right? So what if we have the reverse, right? Too much demand, not enough supply, right? Well, I said there's going to be this other term, not surplus, but shortage. So let's think about it again. I got the same supply and demand schedule. The equilibrium price and quantity we said was what? 3 and 15. If the price is too low, what's going to happen if we move from that equilibrium point to a lower price? Quantity demanded is going to go, so the price is lower. Yeah, someone's holding it. Quantity demanded is going to go up. What's going to happen to the quantity supplied if we lower the price? Suppliers are going to want to produce less. So what's that going to do? All right. It's going to result in prices where the quantity demanded is above my quantity supplied, right? If they started out at the equilibrium where they were equal, quantity demanded is going up, quantity supplied is going down. There is now a gap in between the two. More people want to buy this good than what is currently being produced at this low price. So we would say we have a shortage, right? More people want to buy this good than what's being put out there on the market. So we see this occur with goods when it becomes really, a really competitive market. If we somehow get this artificial price, and we'll talk more about this after the first exam, actually, why the prices might be too high or too low. Usually it's because of the government. But if they were too low, what's going to happen? Companies aren't going to want to produce as much. People would really like to buy it. We end up with a shortage. What's the value of that shortage? Well, we look at the price. The quantity demand is 21. Quantity supplied is 5. I've got a shortage of how many units? 21 people want to buy it. There's only 5 being put out there. So how many people want to buy that aren't? 16, right? Just the difference between the two. Okay. So nothing crazy here, just kind of the reverse of a surplus, right? It's the exact same like procedure. It's just that now we have the quantity demanded being greater than quantity supply. Visually, what does that look like? If we're at this lower price where my quantity demanded was greater than my quantity supplied, I've got this shortage that exists. Well, even though 25 people are willing to buy it when the price is $1, if there's only 5 out there, I mean, if I'm a company and I'm currently selling 5 units at the price of $1, I know there's 16 people out there that still want to buy the good. What might I try to do? Even though I know that every unit past 6, the marginal cost to me is above the current price. In order to produce more units, what might I have to do? Just increase the price. As I increase the price, I'm willing to supply more. But what's true about the quantity demanded? The price goes up. People are willing. Some of these people, their marginal benefit would now be below the price or below their cost. They would no longer want to buy the good. So there's this market pressure when we have a shortage for companies. In order to satisfy this shortage, like this unmet demand, they increase the price, produce more units. However, at this higher price, fewer people are willing to buy, and the value of the shortage starts to decrease. This will continue. They'll kind of keep increasing the price until we get to this point where every single unit being produced is being sold at a price that every single unit is willing, someone is willing to purchase it, right? Or quantity supplied is equal to quantity demanded. Now the value of our shortage would be 0. So in equilibrium, we don't have a surplus or shortage. I guess maybe technically we do, but it's 0, right? It doesn't exist. Okay. Any questions on this idea before we keep moving here? Okay. I won't go over this too much, just because I'm not going to ask specific questions on this and we'll save a little bit of time. But I mentioned, why do these surpluses and shortages exist? Why don't we see the price reach that equilibrium? We just talked about, if it's a free and open market, the market pressures will push the price up or down to that equilibrium point. What might prevent that from happening? Laws, right? So a good example, in the 70s, gasoline, the oil prices technically were rising. So the government kind of put this cap on oil prices to try to limit the price. So they were artificially lowering the price. What would that do? It would cause my quantity supplied to go, quantity demanded would go. So what did we have? A shortage, right? So when the government, it sounds good. Oh, we're going to cap oil prices. We're going to help consumers. Well, yeah, the price is lower. And for the people who get to buy it, we go back to our example. If I had a price of $1 here for gas, right? Who does that benefit? The 5 people who were able to get a gallon of gas, right? Who does it not benefit? This all these people who, even at the equilibrium, would have been able to purchase it are no longer getting it at all. So causing these prices to be artificially too high or too low is not going to be necessarily better for consumers or producers. We'll go more into like the exact how much it does cost them or the actual losses that they would experience in a future module. Right? I believe it's module 5 or 6. To give you kind of another insight in this, we went through this one, this example last class, but we didn't answer this last question. So we solved for the equilibrium price and quantity. If I go ahead and kind of run this example, what if the price was 60? Would a surplus or shortage exist? Okay. So kind of finish out the surplus shortage discussion of how we would use equations to figure this out. Okay. So I've got my demand equation, my supply equation. This is what, 100, well, sorry, price is equal to 100 minus 5Q, and then supply 20 plus 15Q. Okay. We kind of worked through this last class. We do a little bit of math, set these equations equal to each other, and we get what? The equilibrium quantity is, if I'm doing math in my head correct real quick, 4 here. If I set these equations equal to each other and solve for Q, how would I then find the equilibrium price? I would take that quantity and do what? Yeah, well, remember, what is my equilibrium price and quantity representing? So this was the quantity where quantity supplied is equal to quantity demanded, or what does the supply curve represent? Marginal cost. What's the demand curve represent? So our equilibrium price, right? We said the equilibrium quantity is where quantity supplied is equal to quantity demanded. It also happens to be at that equilibrium quantity, it's the price at which marginal benefit of the last unit is the exact same as the marginal cost. Okay. Sorry, can't see the full. There we go. Okay. So I plug this back in to either equation, and I get what? The equilibrium price here is 80. So I had in this question, what happens if the government kind of comes in and sets this hypothetical price at 60? Well, if they set the price below that equilibrium, we know that what's going to happen? The quantity supplied is going to be lower. Quantity demand is going to be, so what do we have? Demand is higher than supply. We've got more people wanting to buy the good than what's being put out there. We've got a shortage, right? What's the value of the shortage? Well, how do I figure out exactly what this quantity supplied and quantity demanded values are? If I know this hypothetical price, what could I do? Plug it into my supply and demand equations, right? So if I do demand, I've got what? 60 is my price. I do a little bit of algebra here. I've got what? 40 is equal to 5Q. Divide both sides by 5. I get my quantity demanded, right, is being equal to, what did I say? Here we go. 8. What's my quantity supplied? Well, my price is 60. Set that equal to. Now it's my quantity supplied. A little bit of algebra here. I get what? Well, this isn't nice and easy, is it? So I've got what? 40 over 15. So this is going to be what? 2.66 repeated. If I'm doing math in my head correct here. Probably would choose values on an exam that nice integer values. But here we can see that quantity supplied at that lower price is less than my quantity demanded. So I have a shortage. What's the value of the shortage here? If I take the difference between these two, it's about what? 5.33 repeated. If I'm looking at this correct. Okay. Huh? Yeah, 5.3. Yeah. Okay. Any questions on this idea before we keep moving? Okay. All right. So where are we at in time? Pretty good. So this is surpluses and shortages. That should kind of take us through the end of module 3. So we will get rid of that. We're then going to start module 4. And I'm going to try not to forget. I want you guys to do this at the end of class. So we'll get to 9 o'clock and I haven't mentioned something about a survey. Stop me. I'll try to stop myself, but I was keeping an eye on time here. I think it's probably best for us to kind of jump in, to kind of keep going with material here. Okay. So we've talked about supply, we've talked about demand. Today, we're really going to focus on just demand, right? I think next class, we'll start to talk a little bit about supply. A lot of the same principles will apply, but we're going to talk about something a little bit different with demand and supply than we did last week. So we're going to talk about elasticities, okay? So all an elasticity is, anytime you see this word elasticity, you can think of it in your head as the responsiveness of something. So if I'm looking at my price elasticity of demand, whatever the second word is, right? So I don't know if this will help, but for some of you, maybe it will. It's kind of weird because, oops, changes in X, right? It's kind of the reverse of how we say it in English. So the price elasticity of demand, that first word, that's what's changing. The second thing, the elasticity of whatever this Y variable is, that's what's responding to that change. So when I have a price elasticity of demand, what that's really saying is, how does demand respond to price changes, right? So this is the thing that's changing. The first word is what is changing. The elasticity of this second thing is what is responding to that change. So the price elasticity of demand is saying, as that price changes, how responsive are people to that change? For example, if I change the price of something, if I change the price of like a house by, I don't know, $100, how much do you think that's going to impact demand? Not much, right? We'll talk about percentage changes here in a second. But I was thinking about that, demand might not respond very much to that $100 change in price. However, if I change the price of a coffee by $100, what's going to happen to demand? It's going to go to, I mean, maybe someone will still buy it, but it's going to plummet, right? It's going to respond a lot. So we're going to think about these price changes of different goods. Different goods, the demand is going to be more or less responsive, right? And we want to have a measure of that, okay? So that's what our goal is with our price elasticity of demand. Now, I kind of cheated. I said, well, what if you change the price of a coffee by $100 or a house of $100? Well, what's true? If I change the price of a house by 100, that's a very small percentage change, right? I mean, if I've got a house a couple $100,000, $100, I wouldn't even notice it, right? That's way less than even 1%. If I even increase the price of a coffee from $5 to $10, what have I done? I've doubled the price. I've increased it by 100%. So we don't care about the change in price or the change in quantity when we're measuring its elasticity. We care about the percentage change. Right? So the way that we're going to measure the price elasticity of demand is it's the percentage change in quantity demanded divided by the percentage change in price. Okay? So once again, if it helps, because we're going to talk about other elasticities next week, any elasticity we're looking at, it could be demand, it could be something else. It's always going to be, if you've got the price elasticity of demand, we'll talk about income elasticities of demand, price elasticities of supply. What goes in your numerator is always the second thing, right? So here it's like the percentage change in whatever that variable Y is over the percentage change in whatever is changing. So for us, if we have the price elasticity of demand, when we're calculating that elasticity of demand, what's going to be in our numerator? Well, I said it's the thing that comes second, right? So it's the percentage change. And how do we measure demand on a demand curve? It's quantity demanded, right? And how is that quantity demanded responding to percent changes in the price? Now, if I calculate it this way, what's the sign of my price elasticity of demand always going to be? When the price goes up, what should happen to the quantity demanded? So what's the value of this thing, or price elasticity of demand always going to be? If this is positive, this would be negative. What if the price goes down? What'll happen to the amount that's bought, or sorry, the amount that's demanded? So what is a negative over a positive, or a positive over a negative? Negative. So this would always be a negative value. Now it gets kind of weird to talk about negative values and being less than, greater than. So generally what we do with this elasticity of demand is we always just kind of look at the absolute value. So putting these, vertical lines, I don't know everyone's math background, but this is just drop the negative sign. We just care about the magnitude. We know it's always going to be negative. So just to make it easier to compare, we're just going to drop that negative sign. Now, I think there was a question on the model reading. And I know there was, because I had a handful of people reach out, and I might not have reached back out to you, where if you enter in the negative value, it's not counting as correct. Because part of the thing is when you calculate these price elasticity of demand, the last step is always you take the absolute value. For the module reading, we hadn't talked about material yet. I didn't want that to be the case. So I'll go back in and kind of update that so it'll accept either the negative or positive value for that module reading. But from here on out, because we've now talked about it, anytime you're asked for the price elasticity of demand, you're always just looking at that absolute value. Okay. That way, when we start to talk about, is this price elasticity of demand for this good higher or lower than another, we can use the correct terminology because we're comparing positive values, right? Okay. Any questions over anything I've set up to this point? Okay with this? Yeah. Yeah, so that's why I started this out kind of with X and Y, because today I think today we're only going to have enough time to talk about the price elasticity of demand. Once we're going to have the features and characteristics of the price elasticity of demand, next class we'll probably focus more on some of the other ones. So we've got like income elasticity of demand, we've got cross price. So how does the percent change in the quantity demanded or quantity supplied when the price of other goods changes, right? So we will talk about different elasticities. Today, we're really just going to focus on the price elasticity of demand. And there's some reasons why. There's some more topics that we have to dive into with it than we wouldn't have to with some of the others. Okay. Any other questions? We keep moving here. That was a good question here. So, it's really pretty easy if I give you percentage changes. So if you look at some of those practice problems, some of the module 4 quiz questions, you will see, if I give you a percentage change in the quantity demanded and I give you a percentage change in price, so here I said what? Netflix decides they're going to increase their prices by 50%. Now that sounds like a lot, but companies do. It's like, I don't remember what the last Netflix increase was, but if I have a relatively low price, so let's say, and we'll talk the midpoint back here in a second, but let's say I had a price to make it easy of $10. What would a 50% increase be? Yeah, not increasing it by 15. What would it? Yeah, I'd raise the price to 15. So it's really only a change of $5. So, that's not a wild example here for Netflix to think about they increase their price by $5, right? That'd be a 50% change, right? Their monthly cost. So if you've got a 50% increase in prices, as a result, you expect to see a 25% reduction in the quantity demanded. Here we end up with negative 0.5. Now I said it's negative. We have one more step, which is what? Right? Take the absolute value, right? We've already kind of jumped the gun here, right? From my slides. It's always going to be negative. We just care about the magnitude. So here we would say the price elasticity of demand is 0.5, right? We just want to know what the magnitude of that value is. So absolute value, right? Once again, I jumped the gun from my slides, but we're always taking the absolute value. So another thing that we're going to do, because it's not really technically correct, the way I described the Netflix example, going from $10 to $15 being a 50% increase. The problem with doing that is if I were to go from 15 to 10, so I decrease the price from 15 to 10, that's moving in the opposite direction. That would actually be a what? A 33%. So moving between the same 2 points on our demand curve, if we start at one point and move the other, we're getting a different percentage change. So what we want to do is use what we call the midpoint method. Oops. So if I'm moving between any two prices, right, I want to have the same elasticity measure. Now, you can make these points as fine as you want, right? We could do this all the way down to like even jumps to the price of a penny, right? But if you're just given 2 points and you're asked about what's the elasticity of demand on this portion of the demand curve, because we'll end up figuring out that the elasticity looks different on different parts of the demand curve. Anytime we're moving between the same 2 points, we want to have the same measure of elasticity. So the way that we're going to guarantee this, because if I just simply do it from taking the change divided by where I started, that's typically how we would think about percentage changes, I'm going to get different values, right? If I move from 100 to 80, or if I move from 80 to 100. We want to have the same elasticity measure. So what we're going to do, I'll put this up here first and then kind of color code it, is we're going to use the midpoint method to calculate this. So remember, what was in my numerator? Percentage change in the quantity demanded, right? So I'll actually, before I show you that slide, this might help some people. So I like to do things if I think it'll benefit at least a good portion of you. So if I've got my percentage change in quantity demanded over my percentage change in price, anytime you want to find a percentage change in something, so I'm just keeping this general with X. If you use the midpoint method, what you're going to do is you're going to say, okay, look, what was the change in that variable I'm looking at? So when I write triangle, that means what's the change, right? I was moving between this first X value and the second X value, right? And I'm then going to divide that by the average of these two. How do I find the average of two numbers? You guys are scaring me. If you have two numbers, you find the average by adding them up and dividing by 2, right? That's all we're doing here. When I want the percentage change in quantity demanded, what I'll do is I'll take whatever the change in the quantity was, divide that by the average of those two quantities. And then if I want the percentage change in price, what was the change in price that resulted in that change in quantity? And then divide that by, well, what was, oops, my parentheses weird there. What was the average of those two prices? So when we calculate percentage changes, the way we do that is we take the change between those 2 points and we divide it by the average of those 2 points. And we've got 2 percentage changes in our elasticity. Also, what did I forget here? Yeah, I got lazy. Absolute value. Okay. Any questions on this before we keep moving? Okay, and I've got it slightly differently in the slide, so you'll have a reference of that equation, right? But those percentage changes, we just said we calculate them as the change in that thing divided by the average. How do I find the change? Well, that's just the difference between the 2 points. How do I find an average? Add those 2 points up and divide by 2, right? And they even have these kind of color coded to what represents what here. Okay. Questions on this before we keep moving? Okay. All right. So let's put some actual values into this. Okay. So let's say, and I'm going to set this up. I'm going to ask a question here in a second. But if I had an initial price of $6, and as a result, I've got a quantity demanded of 15. If I increase the price, I'm sorry, decrease the price to $4, what should that do to the quantity demanded? Increase it. Here, increased it to 25. How could I get these? If I gave you two hypothetical prices, What's something that would help you find the corresponding quantity demanded? We actually looked at one earlier. If I had the demand, so if I know prices, I could plug them into my demand equation and find the corresponding quantities. Right? So we can kind of combine some of what we talked about last week and with this week. I could use that equation to find these different quantities for the two different prices. Okay? Now, once I have those prices and have those quantities, how would I find my elasticity of demand here? Well, what's the change in my quantity demanded? 10. What's the average quantity demanded? If I add those up, divide by 2, I get 20. So 10 over 20 would be 0.5. So I've got a 0.5 in my numerator. What's the percentage change in price? Well, what's the change in price? 2. What's the average price? If I add those up and divide by 2, I would get 10 over 2 is 5. So there, my denominator would be 0.4. So 0.5 over 0.4 gives me an elasticity measure of 1.25. Now, technically, I should have said that the change in price was -2. I ignore the negative sign at the end, so that's why I didn't say that. But you take 0.5 over 0.2, sorry, 0.5 over 0.4, we get an elasticity measure of 1.25. Okay. So this is how you use the midpoint method, plugging in two prices, two quantities to calculate what that percent change was in the quantity demanded and what the percent change was in the price, and then ultimately get your elasticity, price elasticity of demand. Any questions on this idea before we keep moving? Yeah. Yeah, so what does an price elasticity of 1.25 represent? So I've got a couple different ranges here. You're leading up, you're anticipating where I'm going, right? So this is good. In the earlier example, now I forget, I think we had a elasticity measure of like 0.5 or something. It was less than 1. So we've got some different ranges of what the elasticity tells us. So let's think about if I had a price elasticity. Remember, we're taking the absolute value. So what's the only range the elasticity should ever be in? Above 0, right? So let's say we had a price elasticity of demand and it was greater than 1. What does that inherently tell us? So when we had 1.25, what does that mean? Well, remember, I can think of this as the percentage change in the quantity demanded over my percentage change in price, right? Just putting in how we calculate that elasticity of demand, price elasticity of demand. I'm going to multiply both sides here by the percentage change in price. So notice when that price elasticity of demand is greater than 1, what inherently does that mean? It means that the percentage change in the quantity demanded has to be greater than the percentage change in price. So that means whatever the percent change in price was, the amount that people bought changed by a larger amount, right? So if you were going to say this, what does that mean? Consumers were pretty what to that price change? So if their percent change in how much they buy was greater than the percent change in price, they were being very elastic or very responsive, right? So that just kind of more a non-econ term. They're being very responsive to that price change. So anytime we have an elasticity measure over 1, I would say here that consumers were being very responsive. And I said, when I first started talking about elasticity, I said you can think of this elasticity as responsiveness, right? Those two terms are really synonymous. So if people are very responsive to that price change, they're buying way more from like a small change in price. We would also say they're being very elastic, right? So any elasticity measure above 1, we've got elastic demand, right? Or consumers are being very responsive. Now, what if the elasticity is less than 1? Well, we can do the same kind of thing. right? So my percentage change in quantity demanded over my percentage change in price is less than 1. Multiply both sides by the percentage change in price. And I'd be like, right, because anything times 1 is itself. So anytime I have an elasticity measure less than 1, anywhere between 0 and 1, here this would mean the percentage change in how much people bought was a much smaller change than whatever that change in the price was. So you could have really large percent changes in price and people don't really respond, right? They don't buy that much more or that much less. So here we would say that they're very unresponsive, or demand is inelastic. Okay. So greater than 1, that means that consumers are responding a lot to these price changes, or they're very elastic. Less than 1 means they're not being very responsive to these price changes, or what we would say is inelastic. Okay. Any questions before I kind of keep pushing this a little further? I think that these next ones are actually kind of easier. It gets kind of weird. Let's say I had an elasticity exactly equal to 1. Well, I won't go through the entire math, but if I wrote out this elasticity measure, what's the only way that's equal to 1? These two things would have to be equal to each other, right? So if the percentage change in the quantity demanded is like the exact same percentage changes in price, people are like, this isn't really how we should say it, but like perfectly responding, right? We would just say that this, we have a fancy kind of term, which is unit elastic, right? We're exactly matching with our responsiveness, whatever those percent changes in price. Okay? Kind of a one-to-one exchange there. Okay. Any other questions on this before we keep moving? And I think I have this summarized in the slides. So I think this part isn't in the slides. It's always a good thing to pay attention to. What if I had an elasticity measure exactly equal to 0? All right. What would have to be true in order for me to have a price elasticity of demand? Now remember, what does the price elasticity of demand represent? It's the responsiveness of consumers, how much they buy to a change in price. So if I have a price elasticity of demand of 0, that means that when the price of a good changes, how much am I responding? Not at all, right? It would have to be that no matter what percent change I have in price down here, the numerator here always has to be 0. We would kind of say this would be perfectly, well, if I'm not responding at all, it would be perfectly inelastic, right? So our inelastic demand is anywhere in between 0 and being just less than 1. If it is 0, we would say it's perfectly inelastic. Do you think companies like that? Well, if I change the price, if I increase the price and people don't respond at all, they keep buying the same amount, is that a good or a bad thing for who's selling it? It's a good thing, right? Well, why would I decrease the price? Right? Because I know that if I decrease the price, they're going to keep buying the same amount. And if I increase the price, they're going to keep buying the same amount. So if we had true, and obviously nothing is truly, well, actually, some things are truly perfectly inelastic, which is why, like, if you're given given the choice to kill someone to save a loved one, some people choose to kill someone, right? There literally is, they will choose the same quantity of saving their loved one, regardless of what you offer them, right? If you have to kill 10 people, they might do that to sit, well, now we get into like a moral discussion, but this is the idea. If there ever was something that was truly perfectly inelastic, as the producer, I love that. Now I can just increase the price and you keep buying the same amount. Right? Sorry, I don't know why I went so morbid this morning on the killing people, but this is the idea, right? Now this one's kind of weird. What if I had an elasticity of demand? So I said, if the lowest could ever be a 0, what's the highest technically it could ever be? Infinite, right? What would that have to look like? Well, that would mean that no matter what that percentage change in price was, what would my response have to be? Like infinite, right? So this would be like even small increases in price would result in people doing what? If it's an infinite change, when the price goes up, I might go from buying some of the good to buying absolutely nothing, right? Like it would just plummet to zero. Now, is anything truly perfectly elastic? Probably not. Although you could kind of argue there are markets which are pretty close to this. Like if you go to the store, I mean, and this won't be true for every consumer, but there are some consumers and their price elasticity of demand is pretty perfectly elastic. Like if I walk into a store and I'm wanting a drink, like a pop, and I want, cola, I look and I'm like, yeah, if you increase the price of Coke and Pepsi, I'm just going to buy whichever one's the cheapest. I don't really care. I don't have any brand loyalty. So my demand is almost perfectly elastic. You can change the price by a little bit. Pepsi increases their price a little bit. I don't buy any Pepsi. My demand for Pepsi goes to zero. I just buy whatever the cheapest one is, right? So there are some things that have these measures of perfect elasticity, but nothing's probably ever truly perfectly elastic, but they get very close. Okay. So hopefully this kind of helps us think about these different ranges that exist when we're measuring the price elasticity of demand. And so I did all this up here on the board, but here's kind of another summary of it. You can kind of go back to it. Let's see, where are we at in time? I might skip around a little bit. Well, no, I'll kind of stay here. I think we'll save that for next class. All right. So when we're talking about elasticity, we want to be careful. It's not quite the same thing as slope. So it's very easy to think about elasticity and slope as the same thing, but they're not quite synonymous. Now they are related, right? So what would a really steep slope represent? That when the changes in price are really large, what's happening to the quantity demanded? Well, if I had a completely vertical demand curve, if I change the price, what's happening to my quantity demanded? It's not changing at all, right? So there, the steeper the slope, right? I think I said this differently here, but right, the steeper the slope, it's getting closer to being perfectly inelastic, which means that it's having a lower elasticity, right? Something closer to zero. Now, if I have a demand curve that's pretty horizontal, right, there I could see the exact same price charge, and what could happen to the quantity demanded, it's kind of a weird one, could move all over the place, right? So if I had perfectly elastic demand, I'd actually end up with a slope of zero. So these slopes and the elasticities are actually kind of inversely related. The steeper the slope, the lower the elasticity. The flatter the slope, the higher the elasticity. And we'll kind of walk through some examples as to why. And I've kind of already talked about some of these, right? So I jumped the gun on this one already, but let's say I had a completely vertical demand curve. Well, first of all, before we even talk about elasticities, how do I calculate slope? It's the change in, so here, what's my Y? Price. What's my X? Quantity. What would the slope of my demand curve be if it was vertical? The change in Y, or price, would be something here. What's the change in X? Doesn't. So what's my slope always going to be? Well, here, right, I've got a percent change in price. Or sorry, I'm doing percentage change. I've got price over zero. You can't do that, or in the limit, it goes to infinity. Right? So if I'm thinking about, I'm going to jump the gun here a little bit, the slope of a completely vertical demand curve, the change in Y is going to be something. The change in X is going to be zero. Anything divided by zero is infinite. It's really weird. Now, if I wanted my price elasticity of demand, remember, it's like flip, right? What's in my numerator? The percentage change in my quantity demanded. What's on my x-axis? So because I'm flipping that numerator and denominator, the slope and elasticity are going to be inverse of each other. Right? So for a perfectly vertical demand curve, my percentage change in quantity demanded will always be zero. My percentage change in price will be something. 0 over anything will always be 0, right? So completely vertical demand curve, elasticity, price elasticity greater than 0, slope is infinite. They're the exact opposite. Now, what would this also represent? There's a price change. People aren't changing how much they buy at all, so they're going to be very unresponsive, right? Or I think I said here, like there's no price sensitivity. Right? They're not sensitive. They're not responding to this price at all. Now, this is like an extreme scenario. Right? As I start to get a slightly like flatter, right? Not completely vertical, but slightly flatter demand curve. Well, what's going to happen here? Well, I could see that same percent change in price of 10%. But now what's going to happen? The percentage change in the quantity demanded. It's not large. If I have a very vertical demand curve, I could see that 10% change in price, and it's going to change the quantity demanded by a little bit, right? So there might be a really small percentage change in my quantity demanded, something less than that 10%. So if I have what? Choose a number here, 5, 6, 7 divided by 10. All of these would be a price elasticity of demand less than 1, telling us that demand here is inelastic, or that consumers are being pretty unresponsive, right? Not perfectly unresponsive anymore, but relatively low, right? A little sensitivity or responsiveness. And then my elasticity, we already kind of talked about, was something less. Okay. Now, I don't think I have it on here. But, and I said relatively steep, but right, what's the slope going to be? If I were to calculate this slope, if I have a pretty steep slope, that's going to be a pretty large value. It's not going to be infinite anymore, like when it was perfect, but it's going to be still a pretty large value, even though our elasticity is going to be a low value, right? These are inversely related to slope and elasticity. Now, what if I had, right, I kind of already alluded to this, but if I had perfectly inelastic demand, why would I like that? Because I can jack the prices up and people keep buying the same amount, right? So if you don't know, I think what's his name, Martin Shkreli? No, I always want to say the last name of the Recess character. If any of you grew up watching, do you guys know what I'm talking about? Recess? Am I aging myself? It's a really old cartoon. But anyways, whatever this guy's name is, he bought the rights to HIV drugs because guess what? If you have HIV, what do you think your demand for HIV drugs is? Pretty inelastic. I need it so I don't die. So what am I willing to do? You can charge me a lot higher of a price. I'm going to keep buying how much medicine I need, right? You think of insulin, it's the same kind of way. I need whatever amount of insulin I need, right? I don't care what the price is. I need to keep buying the same amount, right? So he bought the rights to this, jacked the price up. It's a whole thing. Google it. It's pretty fun. Like I said, it's like Martin Shkreli or something like that. Anyways, I digress. So what if I had complete opposite, perfectly elastic demand, right? So I had perfectly elastic demand. I could have no change in the price, right? What's the percentage change in the quantity demanded? Hypothetically, it could be higher, it could be lower, but it's going to be something, right? So any number divided by 0, when you have perfectly elastic demand, our price elasticity demand would be infinite. Now, what's the slope of this demand curve, right? Well, slope is the change in y over change in x. What's my change in y? What's my change in x? Something. 0 over something would be 0. Once again, they're exact opposites of each other. And then, we can kind of keep going. What if I had just not perfectly elastic demand, but somewhat elastic? Okay, it's not infinite. It's going to be something greater than 1. That means that I can see that same percentage change in price of 10%. And now the percent change in quantity demanded is something more than 10%, right? People are being more responsive to that same 10% change in price. All right, so we've got elastic, inelastic, perfectly elastic, perfectly inelastic. And I'm not going to waste too much time here. We kind of already went through, but we also have unit elastic, where the percent change in price is the exact same as our percent change in quantity demanded, giving us an elasticity measure of 1. All right. So we are at 8:55. I think we've got enough time to go through this, so I'm going to. And then we'll end it. All right. So we've got elasticity. What impacts this, right? I kind of have already alluded to this a little bit in the examples that I've used, but now I'll start to use a lot more examples where we can think about why elasticity matters. So we know that something is inelastic or consumers are pretty unresponsive to price changes if it's between 0 and 1. They're going to be very responsive to price changes if it's greater than 1. So what makes consumers more or less responsive to these price changes? So the first thing is we're going to think about if I have substitutes. So if I have a good and there's a lot of available substitutes. So that was kind of my example. Well, the other one I think I've got an example here is like I go to the breakfast cereal aisle, right? There's a whole aisle of breakfast cereals, right? If I start to increase my price too much, what are people going to do? Switch cereals, right? So people, when there's a lot of available substitutes, I might not even change the price by much. And what are they going to do? They're going to be very responsive to that price change. You think about this, the other example that's really good for this, gasoline, right? If I've got gas stations on the same corner, if I change my price by a little, what are consumers' demand for my gasoline going to do? It's going to go down a lot. Everyone's just going to go across the street, right? So if you have like very similar substitutes and many of them, people are being more responsive to that price change. They're going to be more elastic. Right? So the exact opposite holds, right? If I have few substitutes or dissimilar, right? So this is my HIV drug example. I'll use diabetes because there's really, to my knowledge, only one thing you can do to kind of help get type 1, right? You need insulin, right? We have my wife and I had a dog who was diabetic, and we actually gave it insulin. It's a lot, but right, it needed the same amount. It didn't matter what the price was. That dog, right, or a person needs the exact same amount of insulin. Right? So there's no other substitute for it. So if there's no other substitutes for this good, change in the price, what happens to how much people buy? If I'm diabetic, and you increase the price by 10%, how much insulin do I buy? I need the exact same amount, right? I don't change at all. So I'm very inelastic, right? Or I'd be less. Now I might change a little bit. Maybe I try to make the same amount go longer. You should not do that if you're diabetic. It's very dangerous, but people might, right? So we might not say it's perfectly inelastic, but if there aren't many substitutes to a good, we would say it's pretty inelastic. Now, a less kind of dire one, but like really unique goods, so like Super Bowl tickets, this is very, topical. There's not really a substitute for the Super Bowl, right? So what happens to the price? We can look it up. The price of Super Bowl tickets is really, really why? They can increase the price and they know how many they're going to sell. All of them. They're going to sell out no matter what, right? Now, obviously, I'm probably used to be a little bit hyperbolic here, but right, people are going to be very unresponsive to those price changes if there's no real substitutes. Okay? And then kind of like one-of-a-kind items, right, are another good thing to kind of think about. Anything that's like signed, right? Typically, we think of there's not substitutes for that. People are going to be pretty inelastic. The next thing is going to be proportion of income, right? So if I'm spending, a large amount of my income on something, so let's say I'm making like housing decisions, right? People will get in like arguments and not buy a house. They'll haggle over like a couple $1,000s. Now, you might be like, well, yeah, it's a couple $1,000. But what is the percent of the price of a couple $1,000s when I'm buying a $200,000 home? It's a very, very small percentage change in the price. But if I'm over this very small percent change in price, I'm willing to not buy the house, go from 1 to 0. I'm being very responsive to that very small percent change in price. So when something is going to be a large amount of my income, I'm really I do my research, right? If I'm buying a new car, I look at all the different cars, I do my research on what the best deal is, right? I might haggle over a very small percent change in the price. Why? Because it's a big decision. Like, it's a lot of my money. So when you have a high proportion of your income being spent on something, if you're more likely to be sensitive to price changes, you're going to be more elastic or inelastic. Elastic, right? So, housing decisions, car purchases, anything that's a large percent of your income, you tend to be a little bit more responsive to price change than that. Now, it's kind of weird because if I have a small proportion of my income spent on something, so like let's think about my day to day, if I'm going to the store, and I'm gonna get, I don't know, I do this sometimes, I go over to the Circle K and I get a fountain drink in the middle of the day, right? Like, it's like $1, right? They could probably double the price, really large percent change in the price, and I might still some afternoon choose to go over again, right? It's a very small portion of my income. So even if there's a large percent change in price, if it's a small portion of my income, I might be very unresponsive or inelastic, right? So we see, you know, fountain drinks, I think is my example, pack of gum, something that just you're not spending a lot of money on. People are not going to be that unresponsive. Another thing that you might see, like public transportation, like bus tickets or things like that, they can actually change the price by a pretty decent percent, and people usually kind of keep consuming the same amount. They're a very small portion of their overall income. But yeah, high portion of your income, you're going to be more responsive. And if this, just to kind of remember this, if you're spending more of your income on something, are you going to be more or less likely to try to make sure you're getting a really good deal? More likely, right? If I'm spending 50 cents on something, a very small portion of my income, am I going to care as much if they increase the price a little bit? And when I say a little bit, it could be a large percent change, right? No, right? So we're going to have this relationship between the proportion of income and how responsive people will be, or their elasticity. The last one I want to kind of go through is the length of time to make a decision. And we've got some good examples for this one. So if I have more time, so the one I always use, if I'm like thinking about going somewhere for spring break, and I was thinking about it last fall, if I have a month, 6 months to make this decision, what can I do over those 6 months? Every day, check to see what flight prices are, right? I'm going to be very responsive because I've got a lot of time to find the lowest possible price. So if I have more time to make a decision, I can be essentially, it's more likely I can find available substitutes. We said if we have more substitutes, we're going to be more elastic. Now, if I all of a sudden, you know, the week before spring break decide I want to go down to Key West, I don't have a lot of time. What do I have to do? Whatever the current price of flights are, I have to pay, right? So I can't be very responsive at all when I don't have a lot of time. Why? Because I have to be there next week. I can't wait around to find substitutes. I have to take whatever is currently available. You kind of think about it that way. So more time, I can be more elastic. I have more time to like find better deals, respond to this change in price. Less time, I don't have as much flexibility to respond to that price. I'm pretty inelastic. Example I'll also use. So this is an economist to me. My wife likes to get coffee, and I like coffee too, but not as much as her. And so Panera has this thing where you like pay a certain amount a month and you can like get unlimited every day. You can stop by and get like an iced coffee. And they're running a deal on it. It's like $3 right now for the first 3 months. And I literally every morning, well, when I teach, it's too early, so I go after. But you just stop by and you just get a free coffee, like as long as you're paying like $1 currently monthly subscription fee. Anyways, I digress. What they try to do, this is genius, and this is why we want to understand elasticity, because if I'm a company, I care about how elastic consumers are. So every morning I go in this app and I go, okay, I want an iced coffee, shows me the price, it's free, because I'm part of this unlimited drink club thing. Every single time, well, not every, most times, as soon as I hit pay, it pops up with this exploding offer where I have 10 seconds to make a decision. If I want to add a bagel for like $1 or add croissant for $2, so all these things. What are they doing? They're giving me a very small amount of time. I can't even look to see. I don't even know if the bagel off the menu costs more than $1, right? Like I have a very low amount of time. I can't even check prices of the same company. So when you offer these like exploding offers, and I know other companies will do this, like Fanatics, I think sometimes will do this when you go to checkout. They'll like put up an exploding offer. You can get this other product for a certain amount off. They're giving you a lower amount of time. Why? Because they know if you don't have as much time, what can you be to change the price? You're going to be less responsive. You can't respond to that price change. They might charge you a higher price and you're going to buy the same amount. Right? So companies do this when they know that like this thing of time, it matters to consumers. Right? So it's one of our characteristics. Okay. I've got some goods here. I might save this and kind of go through some of them. just to revisit these next class. We've got a couple things that I want to do before we end class. We'll pick up here next class. Like I said, we got about halfway through the slides. Thursday's class, we should have more than enough time to kind of cover the remainder of these topics. So what I'm going to do now. Oh, and I have the wrong date on this. I'll change it so it matches up. So this quiz should be available now. We'll kind of talk through some of this. And then I've got another survey I want you to do. So I just like to give these to you to kind of have some problems to work through. We'll kind of talk through them today, and I'll kind of work through them with you. Probably won't do this Thursday since we'll have more time. Thursday, I'll probably have you actually talk with the people around you. Okay? But I'll kind of get some feedback here. So let's say I have the change in the price of a textbook is 24%, and as a result, the quantity demanded of textbooks decreases by 15%. Okay? So I've got my percentage change in price is what? 24. My percentage change in the quantity demand is 15. So when I'm calculating my price elasticity of demand, what goes in my numerator? Yeah, so the thing that's in our numerator is always what is being responsive. So when we talk about the price elasticity of demand, it's how is demand responding to changes in price. So whatever is changing, that price, that's always going to be in our denominator. So if I've got a percentage change in the price of 24%, percentage change to my quantity demand is 15. My elasticity demand is going to be what? Less than or greater than 1? Well, percentage change in the quantity demand is in my numerator, 15 over the percentage change in price, 24. 15 over 24 is less than 1. If we're less than 1, we would say demand is inelastic. Okay? So we can do this for any values here that we have. Okay? Let's say instead, and this would be like problems, even though we're kind of working through them, they're also there for review. These would be good things to go through before the exam or the quiz. Right? So let's say I give you two prices. Right? This gym is increasing their price from what? $20 to $30 a month. And as a result, the memberships they sell goes from 120 to 100. Okay? Now, if I wanted to find the price elasticity of demand here, I'm not giving you the percent changes. How can I find a percentage change? Go back to earlier. I want the percentage change. I'm going to take whatever the change was and divide it by what? The average. So for my percentage change in the quantity demanded, what was the change in the quantity demanded? I went from 120 to 100, so the change is 20. Hopefully this is not difficult. What's the average of 110, or sorry, 120 and 100? Add those together, divide by 2, I get 110. Okay. So I have 20 over 110. That value is going to be in my numerator. What's in my denominator? Well, the price went from 20 to 30. That was a change of what? 10 divided by the average of those two numbers, which would be what? 50 over 2, so 25. So notice, when I have higher values, the same change, right? So if I had like a 10 change, it'd be divided by large. It's going to represent a smaller percentage change when I have really high values. But this would be, this is not what the question asked. We already kind of got through that part. We have what? 20 over 110, then divide that by 10 over 25. Right? I guess that is a big 0.45 if I'm trusting my math here. Okay. Any questions on this? I'm kind of just talking through this. So I would try to maybe be writing this down. All right. Once again, these are good questions to review, things you might see pop up on the quiz or the exam. Okay. So anybody need any clarification on that before we keep moving? I know I'm not writing it out, I'm saying it in words here. All right. If I had truly perfectly elastic demand, so that means if I'm perfectly elastic, there could be changes in the price, and what am I going to do? If I'm perfectly elastic, I'm going to be very, very responsive, which means if you increase the price a little bit, my quantity demanded goes all the way to 0, basically. Right? When I change the price a little bit, I stop buying that good. So we said perfectly elastic demand would be a horizontal demand curve where you can only charge one price. If you try to charge any price different than that, quantity demand is going to go to 0, right? So there, I've got not a vertical demand curve, but a horizontal demand curve. What would the slope of a horizontal demand curve be? 0, right? That percentage change, that change in price would be 0 over a change in quantity, something 0 ranging to 0. What might elasticity be? Well, there, the percentage change in price is 0. When I'm calculating my price elasticity of demand, that's what's in my denominator. So anything over 0 is going to be infinite. So I should have a price elasticity that's not 0, but is infinite. My slope will be 0, though, right? And then, we said, if I'm perfectly elastic, am I being responsive? I'm being very responsive. So we know that one doesn't make any sense, right? I'm being very responsive. It's not that I'm not being responsive. All right. So another thing before we get out of here. Before you get those, make sure you get those quizzes submitted. And this should take you not too long. If you guys don't mind doing this. Actually, I don't have to have this done until Friday. So we'll have plenty of time on Thursday's class. I'll start Thursdays, but just to kind of set it up. So before you get too loud and pack up, I'm doing something this semester where I'm taking like this course on, it's whatever. I'm trying to be a better teacher, right? I'm trying to find ways to not so much better teacher. It's a way to help you guys improve your learning, right? So a lot of it is setting things up in a way that I know this class is difficult. I know this class can be tough, right? Just because we have early failures doesn't mean you're like doomed for the rest of the semester, right? And so there's different ways and different techniques that I can convey to you and kind of give you some feedback so that you don't get discouraged, essentially. And you shouldn't. You can do very poorly on the first couple of quizzes. That's part of the reason why I drop quizzes, or I drop a something, because a kind of rough start in this class does not mean you're doomed for failure, right? There's always room to kind of better improve your study techniques, different topics, like they might just click with you better than some of the earlier ones. So that's a little bit of what this is about. I'm going to do a couple surveys. I think there's one in now, a little bit further in, and then one at the very end. So I'm going to have you guys fill this out at the beginning of class on Thursday, and then we'll jump into the rest of the material from Module 4. Other than that, what should you also make sure you're getting done by the end of the week? I didn't mention at the beginning of class, that first pack back assignment is due by the end of the week, right? So if you haven't done that yet, make sure you're getting on and getting that done. That's the only thing that you should currently have. Where is it at? Up there on Canvas. Other than that, I'll see you guys on Thursday.